Hello guys, so I would like us to look at how to go about evaluating this particular integral here. So, solution, we're going to use integration using partial fractions. So I'm going to decompose it into its partial so let's have 1 over x into x squared plus 1. This can be written as a over x plus bx plus c over x squared plus 1. Okay, then putting this under the same LCM, so we will have this as x into x squared plus 1, then x goes here, x squared plus 1, then plus bx plus c. X squared plus 1 goes here, x times, and this is supposed to be equal to 1 over x into x squared plus 1. So we're going to take random values of x and replace in the numerator and solve so that we get the values of our unknowns a, b, and c. So I'm going to take when x is equal to, let's say, 0. So in the numerator, I have 1 there. When x is 0, I'll have a there. When x is 0 and 0, I'll have 0. So that gives me a is equal to 1. When x is equal to, let's say, 1, so when x is 1, we have 1 here. X is 1, 1 plus 1, that will give us 2a. When x is 1, this will be b, and then this will give plus b plus c. Since you already know the value of a is 1, so replacing here, we'll have 2. So 2, bringing 2 to this other side, we'll have 1 minus 2 is equal to b plus c. So this basically gives b plus c. B plus c is equal to minus 1. Then taking another random value of x, when x is, let's say, equal to minus 1. So we'll have 1 is equal to minus 1 squared. That will give us 2a there, minus 1, and then minus b, that will give plus b, minus 1, and c, that will give minus c. But you already know the value of a is 1. So replacing 1 here, 1 minus 1 will be 0. 0 is equal to b minus c. So bringing c to the other side, we'll have that c is equal to b. Now, if c is equal to b, and from here we have that we can be able to replace the value here so that we have b plus, instead of c, let's just write b is equal to minus 1. So this gives 2b is equal to minus 1. So b is equal to minus a half. So if b is minus a half, c is also minus a half. Then replacing these values now into our equation, we'll have a is 1, so 1 over x, 1 over x plus bx, so minus a half x minus a half, all this divided by x squared plus 1. So this is what we are going to integrate, and the integral is from 1 to 2, 1 to 2 dx. So can be able to distribute this so that we have integral from 1 to 2 of 1 over x dx plus integral from 1 to 2 of this here minus a half x over x squared plus 1 minus a half over x squared plus 1 dx. So the first part, integrating 1 over x, we simply get ln x. Integral is from 1 to 2, the range. And then here, if we integrate this, so this is going to give us a logarithmic function. Since if we differentiate x squared plus 1, we should get 2x. However, here we have minus a half. So in order for us to get a perfect ln, we can be able to remove the minus a half out there and introduce 2 and remove it at the same time. What I mean is I can write this as 2x over x squared plus 1 and then divide by 2. So I've removed this, haven't changed anything because this 2 can cancel with this. I just want this to be giving me a perfect logarithmic function. And then on this other side, I can be able to write this as minus a half integral from 1 to 2 of 1 over x squared plus 1 dx, because this is going to give me also. So here I have, so this is equal to ln x, integral is from 1 to 2, and this right here, minus a half divided by 2, that will be minus a quarter. This gives me ln x squared plus 1. Range is still from 1 to 2, and here this is minus a half. The integral of this is tan inverse x from 1 to 2. So we can just write this and then replace the ranges. So we have ln x minus a quarter, ln x squared plus 1 minus a half tan inverse of x. Integral is from 1 to 2. So replace the ranges with 2, then minus 1. So this will give ln 2 minus a quarter, ln 4 plus 1 minus a half tan inverse of 2. Then all this minus ln 1 minus a quarter, ln 1 squared plus 1. So that is ln 2 minus a half tan inverse of 1. That is how we go about it. So we can input those values and get our answer.